But if there's nothing else, let's move on to Max Grover talking about open radar science in action.
Awesome. Let me go ahead and share my screen here. All right.
Looks
you
good.
See that okay?
Yep.
Alrighty. So today I'll be discussing an overview of the open radar science community with a couple of ARM-focused highlights here. And then just some background on myself. I'm a software developer at Argonne National Laboratory working on various ARM type things. So like I mentioned before, so this is the open radar science community. So what is this traditional radar workflow? So typically there's observations. This is an example from the Sail Field campaign in Colorado. And traditionally it's run through this proprietary software. And then you finally get some analysis and insight towards the end. So one of the limitations of using this proprietary software, say for example, MATLAB or one of the vendor-specific pieces of software, is that it's costly. There are licensing fees involved. Some of the data you sort of get locked into whatever sort of formats and such, and it can be very very limiting, especially in terms of the siloing. So you have different organizations that are all sort of developing their own solutions to these types of workflows, and you get the non-invented here syndrome a lot, where basically people will reinvent the wheel every time they're trying to work with these types of data. And then also it's exclusive. So especially for sort of what we're talking about this week with the idea of wanting open and accessible proprietary software where you're locked in like this and you have to pay these licensing fees, it's really limited to those who have the money to be able to pay for that sort of proprietary software. This has been an issue for a while within the community, and this is why the open radar science community came along. So the key difference here is highlighted in the middle, where moving more towards GitHub and this community open source software, where you can take your observations, plug them in through these different analysis codes, and you get the analysis insight towards the end there. So the advantages of this approach is that it's free, open source, and cross-organizational. So really fostering collaboration across different organizations, for example, ARM, and along with our collaborators and such in Europe, and really focusing on developing this code together. Being able to leverage existing organizational funding mechanisms, for example, ARM funds a portion of this development, especially in terms of PiArt, which I'll get to here in a bit. And it's inclusive. So this is free and openly available. We provide the documentation. We provide examples of working with these types of data. And we're trying to get as many people sort of locked into this and being willing to contribute to this as well. And generally creating this community where we work together to tackle some of these data and analysis issues. And this is nothing new. So this is an initiative that was started even early in 2012. So this has been around for about 10 years now. And I'll be highlighting some of the parts of this ecosystem today. So how do we collaborate? Like I mentioned before, it's all on GitHub. So specifically this open radar community. And there's a variety of languages. So as you see, it's mostly Python, but then there's also some of our collaborators, especially the LROS core, that's written in C++, as well as Java, which is some of the Vault-Rad content there. And specifically within the Python stack here, we have PiArt, which is what I'll be highlighting today. This is just one component of this community. We also have Radlib. It's developed primarily by people over in Europe. And then PyDDA is an example of dual Doppler synthesis, primarily led by Bobby Jackson. So this community all works together. It focuses on interoperable programs here, where you can use one to pass it into the other, and again, really focusing on fostering that collaboration. So who's all collaborating on this? This is just a subset of some of the organizations people have contributed from. So everywhere from, you see ARM here, we see University of Illinois, Argonne, Nebraska, National Weather Service, as well as sort of all over the world. So it's really neat that this brings together so many different people, and we can help solve some of these issues. So one component of the OpenRadar ecosystem here is PiArt, which is funded by ARM, originally created by Scott Collis. So PiArt Central Core is a data model for gated data with pointing information. So you can see some examples on the right here. This is some ground-based radar imagery where we have PiArt reading in some file and then plotting some of this. So you can see reflectivity, you can see the gate IDs here. You can see a neat animation. This is from the XAP or the SGP site, looking at some deep convection. And so, yeah, PiArt created a way of representing radar data in the Python programming language that mirrors CF radio, which is one format of radar data. And PiArt has numerous sort of correction tools, retrieval tools, and gridding tools that make it easy to work with different types of radar data. And like Scott mentioned before, so this is one of the packages where it has a defined roadmap. It has a specific scope, and the idea here is to do less better. So really to focus on the things that it does well, and do those things very well. So how has PiArt grown? So this is a similar graph to what Scott was showing earlier. So you can see here, so the darker blue are external contributions, whereas the light blue is internal, where internal basically means it's somebody funded by ARM to work on this. So you can see at the beginning, back when it was basically just Scott, along with one other developer, things started pretty small, where you might have had one or two external contributors. But over the years, especially by the time you get to 2018 and 2020, the external contributors far outnumber the internal contributors by quite a bit. And this just sort of shows the power of sort of being ARM supported and funding a lot of this development work and basically being managed from the ARM side, but then really developed by the community and for the community. And then on the bottom right, you can see some of the latest download statistics. These are monthly downloads. So getting close to 20,000 downloads a month. So this is a very popular package. People use it quite a bit, not only with ARM data, but also ground-based radar data across the United States, the NextRad network, as well as all different types of radars around the world, especially in Argentina. So it's pretty powerful to see the growth of this package, the growth of this community, and how awesome this open source community could be towards tackling these issues. And how has PiArt enabled open science? So you can see an example of some of the peer-reviewed journal articles that have cited PiArt explicitly. So you can see one looking at vertical air motion retrievals, looking at the MC3E field campaign, as well as the Galapagos cacti field campaign in the Sierras de Cordoba region in South America. So really all over the world. And you can see the bottom right, this was the Journal of Open Research Software put together by Helmus and Collis. And so that paper alone has close to 150 citations. So it's great to see people getting credit for this work and really seeing how it enables all this progress using both ARM data and using some of these tools that ARM has funded. So how do we continue to grow our community? So support of existing users, so continue to improve outreach and examples, especially, and encourage contributions and provide feedback on those. So adding new features, so like Scott mentioned before, looking towards supporting the X-ray data model, aligning with the Pangeo ecosystem, which is sort of a broader earth science community focused on tackling especially some of these big data problems that's really grown over the past few years. And also putting together new cookbooks focused on working with ARM along with other data. So especially some of the value-added products, putting together cookbooks on creating those, and really just showing how to use PiArt as well as the rest of the OpenRadar stack to be able to do this analysis. The nice thing about those those are provided asynchronously, so even if somebody doesn't necessarily have a chance to attend ERAD, the European Radar Conference, the American Meteorological Society Radar Conference, or the AMS annual meeting, that they'll be able to access some of these materials asynchronously and be able to follow along and see how to do all this open science. And then other outreach opportunities, so attending regional workshops and teaching people how to use these tools, as well as engaging with the scientific Python, the SciPy community through their annual meeting. So what are we currently working on? What's next? So like I mentioned before, looking at creating these cookbooks, and then especially working with some of these different workshops. So there'll be an open radar session at the European Radar Conference coming up later this year. And there'll be a workshop on working with the SAIL field campaign data at the AMS annual meeting in early 2023 in Denver. Which will be showing how to use these different packages to be able to analyze data from that field campaign. So really focusing on that open science aspect, and like Scott mentioned before too, really focusing on the workforce development and getting people more on this this open science, open radar train. So I'll just point at the end here to the radar cookbook. I'll go ahead and drop this in the chat, but this is the current prototype of that. So again, it sort of covers an overview of how to use the package. It links to the existing Project Pythia content, which John Klein will be talking about here in a bit. But we're really excited about what's coming up soon for the Open Radar community. And again, thank you to the ARM community for funding these efforts and really enabling open science and the support of open source software. And at this point, I will take any questions.
Okay, any questions for Max? I guess I will start out with the other systems or software available in this open source ecosystem around Open Radar. You know, does ARM use any of these others like RadLib or PyDDA in their software processing?
Yeah, so I know at least the RadLib package has some really great tools for dealing with beam blockage, which is used within some of the value-added product development, as well as PyDDA is used for several of the value-added products. LROs could be helpful when dealing with some of the data conversion and data formats. So yeah, all these packages are used interchangeably, and it really helps with, especially the value-added products, that development. It's really helped with that process.
Great. We got a hand up, Jim.
There we go. Thank you, Max. So I guess I was struck by the plot that showed the the contributions. That's remarkable. And I guess a question I have with these external contributions, how do you manage what's appropriate to make part of the core Python or PiArt package versus not? Could you outline how that process works?
Yeah, so Scott, like Scott mentioned earlier, we always want to keep our roadmap in mind, and we have so the way that the GitHub sort of works is we have the pull request workflow where basically somebody will introduce a new feature. The managers of that repository are Scott, Zach, and myself. So basically, we will go through, review the edition, decide whether or not it's suitable, provide feedback to the contributor, and then ultimately decide whether to approve or disapprove the changes. We also have a bi-weekly meeting that's open to anyone who's interested in contributing to this process, where we'll sort of highlight some of the upcoming changes, some of the area where we need some of these contributions. And it's a good forum for sort of discussing what's of the highest priority, the scope, and so on.
Great, thank you.
Absolutely.
So I guess, Max, that does highlight the importance of, defining your scope ahead of time for any sort of, community type of toolkit or code base that you're wanting to develop, right?
For sure. Yeah, and an example of that, so PiArt really focuses on the I/O, input output, some of the corrections and the gridding, and then finally the visualizations. So that's all highlighted within the roadmap. But again, yeah, it's important to sort of have an idea of your scope and not not try to do too much.